The Egyptian pyramids are among the most iconic and mysterious structures ever built. Towering over the desert, they continue to awe and inspire people from around the world. But beyond their grand appearance lies an even more fascinating truth. These were not just monuments to pharaohs. They were masterpieces of engineering, constructed with knowledge and precision far ahead of their time. This is the story of the hidden engineering behind the pyramids. To understand the scale of their accomplishment, imagine beginning a construction project with no cranes, no bulldozers, no modern surveying equipment. Now imagine that project involves more than 2 million stone blocks, each weighing up to 80 tons, arranged into a perfect geometric structure, almost 500 feet tall. The Great Pyramid of Giza stood as the tallest structure on Earth for nearly 4,000 years. It wasn't just a tomb, it was a statement of technological power and mastery. The ancient Egyptians faced immense challenges before a single stone was ever laid. Choosing the right site was the first hurdle. The foundation had to be solid, stable, and capable of supporting millions of tons of weight for millennia. The location needed to be close to both labor and materials. It also needed to be oriented perfectly, not just geographically, but cosmically, in alignment with the stars and the cardinal directions, and somehow they achieved it. The Great Pyramid is aligned to true north with incredible accuracy, within just a fraction of a degree, a precision that's hard to match even with modern equipment. How did they do it? They used simple tools and deep observation of the natural world. Ancient Egyptian engineers likely used the stars, especially the circumpolar stars that never set, to establish north. With a tool called a merket, essentially a sighting instrument with a plumb line, they observed star movements and marked where they crossed the sky. They also used sun shadows and vertical poles to determine exact east-west alignment. Through a combination of astronomy and geometry, they created a reliable surveying system with nothing more than wood, string, and stone. Once the site was selected, it had to be leveled, and not just roughly, precisely. The base of the Great Pyramid is leveled to within a few centimeters. Some theories suggest they used water-filled trenches to find the high and low points in the bedrock. Wherever the waterline showed variation, they would chip away until the surface was uniformly flat. This kind of foundation preparation is essential in modern construction, but it was practically unheard of in the ancient world. Yet the Egyptians did it, over 4,000 years ago. Next came the materials, an engineering challenge of its own. The bulk of the pyramid was made from limestone, quarried locally, but the outer casing, now mostly gone, was made from highly polished white limestone brought from Tura, across the Nile. Transporting thousands of tons of stone across river and desert was no small task, and for the interior chambers, like the King's Chamber, they used granite from Aswan, over 800 kilometers away. Some of these granite blocks weighed as much as 80 tons. How were they moved? Evidence suggests they were floated up the Nile on large boats, then dragged across land using sledges. Dragging massive stones across desert sands is incredibly difficult, unless you know a trick. Recent discoveries show that Egyptians may have poured water onto the sand in front of sledges. The damp sand reduced friction dramatically, allowing them to haul stones more efficiently. This simple yet brilliant insight was not just about brute strength. It was a practical application of physics. They didn't need to reinvent the wheel. They needed to understand how the natural world worked and use that knowledge cleverly. Labor was another massive component of the project. Contrary to popular myths, the pyramids were not built by slaves. Archaeological evidence suggests that skilled workers were involved, masons, architects, engineers, and laborers, and that they worked in rotating teams. These workers lived in nearby camps and were well fed, supported, and even provided medical care. Some of their names, inscribed on blocks, have survived. These were proud craftsmen, not enslaved people. Organizing and feeding a workforce of tens of thousands required meticulous planning, storage, supply chains, and logistics. It was engineering not just of stone, but of people. Then came the challenge of building. How do you lift multi-ton stones hundreds of feet into the air with no cranes? The most widely accepted theory involves ramps. These could have been straight ramps, zigzagging ramps, or spiral ramps. As the pyramid rose, so did the ramps. Some theories even suggest internal ramps hidden within the pyramid's structure itself. These would spiral upward, protected from the elements and giving access to higher layers. Regardless of which ramp system was used, the placement of each block had to be precise. Joints between stones were sometimes so tight that even a razor blade couldn't pass through. This wasn't careless stacking, it was precision fitting. Workers used copper tools and dolerite pounding stones to shape each block. They used levers, sleds, ropes, and wooden rollers to guide each stone into place. This level of craftsmanship required planning, coordination, and constant quality control. Mistakes were not an option. A misaligned block could throw off the entire structure, but the genius didn't stop at the exterior. Inside the pyramids lies some of the most sophisticated structural engineering of the ancient world. The Great Pyramid contains a series of internal chambers and passageways, each with its own engineering challenges. The King's Chamber, constructed from enormous granite beams, is a marvel of load-bearing design. Above it are 5 relieving chambers filled with huge granite slabs. Their purpose? To distribute the weight of the pyramid and prevent the chamber from collapsing under pressure. This is load management on a massive scale, a concept still vital in modern skyscraper design. Then there are the air shafts, narrow tunnels leading from the king's and queen's chambers to the outside. For a long time, they were thought to be purely symbolic, but new theories suggest they may have served real ventilation functions, or perhaps acted as alignment channels to specific stars. These shafts were not afterthoughts. They were built into the design from the start, requiring precise calculations and placement. Their existence shows a fusion of spirituality and science, something common in ancient Egyptian architecture. The pyramid's shape itself is an engineering decision. The sloped sides reduce the load on any one part of the structure. They also allow for efficient wind deflection and minimize the chances of structural collapse. The pyramid is one of the most stable architectural forms, and the Egyptians chose it not just for its symbolic power, but because it works. Even today, modern architects recognize the inherent strength of the pyramid form. And what about durability? These structures have withstood thousands of years of earthquakes, sandstorms, and erosion. Much of that is due to how they were built, on solid bedrock, using materials resistant to weathering, with joints that minimize water intrusion. There are few modern structures that could last even a fraction as long without major repairs. The pyramids are a lesson in longevity, built to outlast empires. Despite all this knowledge, many questions remain. We still don't know exactly how the Great Pyramid was built. There are no blueprints, no ancient manuals, no carved instructions. Everything we know has been pieced together from archaeology, experimentation, and logical deduction. It's entirely possible that ancient Egyptian engineers had tools and methods now lost to time. Ingenious devices made of wood or rope or copper that didn't survive the centuries. Their secrets may still lie hidden beneath the sands. But what we do know is enough to inspire awe. The construction of the pyramids required more than muscle. It required imagination, intelligence, and an understanding of physics, geometry, and materials science. It required logistics, management, and a clear vision of what could be accomplished when people worked together toward a shared goal. The pyramids stand as silent monuments to what humanity can achieve without modern machines, using nothing but brain, brawn, and belief. They are proof that great engineering doesn't require advanced technology, just deep understanding and daring vision. When we look at the Great Pyramid today, we're not just looking at a tomb. We're looking at one of the greatest engineering projects in human history, one that continues to teach and challenge us even now. Thanks for watching. If you found this journey into ancient engineering as fascinating as we did, be sure to hit that like button and subscribe for more deep dives into the genius of human innovation, past and present. And got a theory or question about how the pyramids were built? Drop it in the comments. Until next time, keep exploring, keep questioning, and never stop being amazed by what humanity can build.